Figure 3.1, calculating a p-value. The p-value is the probability of drawing a value of big Y bar that differs from mu sub big Y naught by at least as much as big Y bar superscript act in large samples. Big Y bar is distributed big N open mu sub big Y naught and sigma sub big Y squared under the null hypothesis. So open big Y bar minus mu sub big Y naught close over sigma sub big Y bar is distributed big N open 0 and 1 close. Thus the p-value is the shaded standard normal tail probability outside, plus or minus the absolute value of big Y bar superscript act minus mu sub big Y naught close over sigma sub big Y. And we have the graph. It looks like a normal distribution shape. The p-value is the shaded area in the graph, and there's 0 in the middle. And on the left axis, we have negative absolute value of big Y bar superscript act minus mu sub big Y naught over sigma sub big Y bar, and just positive on the same on the right side. And on the horizontal axis is Z. The sample variance, sample standard deviation, and the standard error. The sample variance, S sub big Y squared is an estimator of the population variance. Sigma sub big Y squared, the sample standard deviation, S sub big Y, is an estimator of the population standard deviation, sigma sub big Y, and the standard error of the sample average, big Y bar, is an estimator of the standard deviation of the sampling distribution of big Y bar. The sampling variance and standard deviation. The sample variance, S sub big Y squared, is S sub big Y squared equals 1 over n minus 1 times the sum of from I equals 1 to n of open big Y sub I minus big Y bar close squared, equation 3.7. The sample standard deviation, S sub big Y, is the square root of the sample variance. The formula for the sample variance is much like the formula for the population variance. The population variance, big E of big Y minus mu sub big Y squared, is the average value of open big Y minus mu sub big Y close squared in the population distribution. Similarly, the sample variance is the sample average of open big Y sub I minus mu sub big Y close squared, I equals 1 through n, with 2 modifications. First, mu sub big Y is replaced by big Y bar, and second, the average uses the divisor n minus 1 instead of n. The reason for the first modification, replacing mu sub big Y by big Y bar, is that mu sub big Y is unknown and thus must be estimated. The natural estimator of mu sub big Y is big Y bar. The reason for the second modification, dividing by n minus 1 instead of by n, is that estimating mu sub big Y by big Y bar introduces a small downward bias in open big Y sub I minus big Y sub bar close squared.